Hey, 8th grade. So our learning target today is I can predict the graph of a quadratic equation y equals a times x squared. So what we're going to talk about is things that are not linear anymore. The minute we get this power in here, we have something that's not linear. So that power is going to make it exponential or quadratic in style. So our linear equation then would be y equals mx plus b. Straight line equation, same slope, same growth all the way. Nice straight lines, kind of the stuff we've been doing all school year. We've recently talked about exponential when we have this multiplication division growth versus addition subtraction. Remember, the growth here in linear is when we grow through addition and subtraction. Exponential is when we grow through multiplication division. Sorry, this pen is acting up on me here a little bit. So what we're going to talk about next, and it's called exponential here because of the power. Quadratic is specific in that the power is 2 in a quadratic function. Y equals ax squared plus bx plus c. Keeping in mind that this is a number, that's a number, and that's a number because they're variables. And you know variables in math are really just numbers that are unknown. We can find when we usually can find them out, but they're temporarily unknown. So, linear, exponential, quadratic. What we learned in linear is that it's just a straight line. We've been doing that all year. So if we take an equation like y equals 2x. So my slope is 2. Now notice in this particular problem that the b value would be 0, right? We'd start at 0 there. All right. So if we were to pick some input values, -2, -1, 0, 1, and 2, we would just substitute in. Or we can fast graph that, but we'll follow the pattern. Y equals mx plus b, knowing this is a straight line. Substitute -2 into the equation. We have 2 times -2, which is a triangle problem of -4. Substitute -1 into the equation. 2 times -1 is -2. Substitute 0 into the equation, we get 0. Substitute 1 into the equation. We get 2. Substitute 2 into the equation. 2 times 2 is 4. So there's our input and output table. Let's go ahead and graph that. It's a nice straight line graph. We go left 2, down 4. Now, if I'm going too fast, go ahead and pause that video, but I'm going to keep on plugging away here. Left 2, down 1, 2, 3, 4. There's your data point. Left 1, down 2. There's your data point. Graphed that one, graphed that one. The origin, 0, 0. Right 1, up 2. Right 1, up 2. There's your data point. Right 2, up 4. Right 2, up 4. Linear, nice straight graph. Y equals mx plus b. This is the equation y equals 2x. All right, so then we also have something called exponential. Remember linear we talked about is when you add or subtract the same amount all the way through the table. So in this particular case, we're adding 2. Exponential is when you multiply or divide in the pattern. So if we pick those values, we would use an equation something like y equals base 2 to the x power. So in that particular case, we're saying that we're doubling our data points. So -2, -1, 0, 1, and 2. I want to use the same input so we're consistent with our work here. We substitute in, well, 2 to the -2nd power. Anytime you have a negative power, it means it's super tiny. It's a fraction, super tiny. It's the fraction 1/4. You can go ahead and throw that in your calculator if you're confused on where I got that, but it's a fraction 1/4. Then substitute -1 in. 2 to the -1st is a fraction 1/2. Substitute 0 in. 2 to the 0 power is the whole number 1. Substitute 1 in. 2 to the 1st power is 2. Substitute 2 in. 2 to the 2nd power is 4. Graphing. So you can see some of the data points to be similar. We're going to go left 2, up just a tiny bit, up 1/4. Left 1, up 1/2. 0, up 1. Right 1, up 2. Right 2, up 4. So we have this nice exponential growth graph. You can see it's not a straight line. You can see that it's doubling. It's growing quickly. Exponential growths grow tiny. They grow a little bit at the beginning and then they explode after that. And the new graph that we're going to learn about is called a quadratic. Quadratics have to have a power of 2. So it'd be y equals x squared, let's say. Y equals x squared. So to keep in mind, there's kind of a 1 in front of here. So -2, -1, 0, 1, and 2. Using substitution, we're going to substitute in. Make sure we protect that power. -2 to the 2nd power is +4. Plug in the -1. -1 to the second power is +1. Plug in 0. 0 to the second power is 0. Plug in 1. 1 times 1 is 1. And plug in 2. 2 times 2 is 4. Now this is known as a quadratic because of the power of 2. Left 2, up 1, 2, 3, 4. Left 1, up 1. 0, 0. Right 1, up 1. Right 2, up 4. Now I know I kind of graphed that fairly quickly. Go ahead and catch up. Anytime you have the power of 2, you're going to end up with a U-shaped graph. That's called a quadratic. Go ahead and catch up there, U-shaped graph. You can see those three graphs are all very different in style. All right. So some key terms. A parabola is a U-shaped graph. So anything that's quadratic. So quadratic. So things like y equals some number 2x squared plus 5x plus 3. This is the key right here. We need that power of 2 on that x, y. This is known as the quadratic. All the other things in that are just shifting the graph around the place, but that gives us that U-shaped graph when we have that y equals some number x squared. This is next term here is called the line of symmetry. We call it the LOS just to abbreviate it, make our life a little bit simpler there. But it's the place where you divide curve into 2. And it's the very similar to symmetry that you did in elementary school where you would maybe fold a piece of construction paper and you would cut out a heart. And when you unfold that, you end up with 2 equal parts of the heart. And then the vertex is the place, and this is a little bit confusing until you see an example of it. So I just need you to get the notes down right now and then we'll talk. It's the place where the line of symmetry known as the LOS, where the line of symmetry intersects the parabola. Go ahead and get those notes in. Where the line of symmetry intersects the parabola. So we'll talk through those vocabulary words as we go. And maybe I'll put a little simple example here. So we have this U-shaped graph known as a parabola. So when we're talking about the line of symmetry, it's literally the place where we cut that into 2 parts. The line of symmetry is the place where the U-shaped graph intersects, known as the this is our vertex right there, where the line of symmetry hits the base of the parabola. So let's look at our first example here, the line of symmetry. So if we were to construct this into 2 equal parts, we're going to go ahead and draw that vertical line. That gives us that nice, beautiful split there, just like you did in elementary school when you were trying to cut out that heart-shaped graph. There's my line of symmetry. The equation on that line is the x value is equal to 2 there. So the actual equation is x equals 2. Looks a little bit different because we're so used to everything being y equals. But that's what happens when we have an undefined vertical slope. It's the x value. The vertex is the place where the red line hits the blue parabola on my screen. So you're going to have to look at my screen to get those colors figured out. This is our vertex. So our vertex is over to the right 2, down 2. So our vertex is at 2, -2, that blue dot. All right, let's talk about this parabola over here to the right, which is actually going out upside down. We'll talk later in the hour about when that happens in tomorrow's work. So our line of symmetry is the place where we cut that into 2 parts. So right here. That's happening actually right on the x-axis. So the x in that place is actually 0 there, right on the x-axis. Many kids want to write y equals 0 there, but that is actually not the equation of that line. That equation of a line is x is 0, because all the x's are 0 on that line. The y's are, actually changing. So the vertex is the place where the purple line and the red parabola hit. And that's happening right here. So that's my vertex up at 1, 2, it looks like 3. So we're going to go over 0, up 3 would be known as the vertex. Go ahead and get those notes taken. All right. So here we go on the top of the next, or where am I at? We're at the bottom of that page, my fault. So as we start to graph and compare some things. Let's look at a graph that has y equals x squared. Now keep in mind that the number in front here is really 1, and we call that our a value. That's going to be our a value. We'll talk through that in our work today. Over here, we're going to have a negative 1. That's going to be our a value. So we're going to look at the difference between when the a is positive, what happens, compared to when the a is negative, what happens. So using substitution, we're going to substitute all these in. When you do that, I need you to put parentheses around all of these as you substitute. Remember that whole power thing with a negative gets a little funky. So we substitute in with a parenthesis around the -3. We have -3 to the second power, which really means I need 2 of those. That's -3 multiplied by -3. Answer should be 9. You can use your calculator if you're struggling on your integers. Otherwise, try to plug through as many of these as you can without. Substitute -2 in. -2 to the second power. -2 times -2 is +4. Substitute again. -1 times -1 is 1. Substitute again. 0 in. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So as we graph those, let's go ahead and graph and see what happens with when the a value is positive. We're going to go left 3, up 9. So we go left 1, 2, 3, up 9. That's not going to fit on the graph, so we're going to skip that one. Left 2, up 4, left. Let me darken these lines in so you can very clearly see the difference between the y-axis and the lines. Sorry, they got a little fuzzy here. All right, there's our coordinate plane. So let's go ahead and graph that. Left 2, up 4, left 2. Up 1, 2, 3, 4, lock it in. Now this should be a U-shaped graph because it has a power of 2 there. Left 1, up 1. So we go left 1, up 1. 0, 0. Right 1, up 1. Right 2, up 4. Now they should match on the left and the right-hand side if that truly is our line of symmetry, and that one's not going to fit on the graph. So we get this nice, beautiful U-shaped graph. It splits right down the middle of that. And there we have the parabola where the a value is positive. So this is our parabola, y equals 1x squared. So we get the U-shaped graph. We have an a value of 1. It's positive. That's what it looks like. Same thing over on the other side. Now we're going to throw parentheses around these. So keep that in mind when you're doing that. So there'll be a negative on the outside. And then we throw parentheses around that as we substitute in. So we substitute in. So that's really y equals -1 times -3 squared. Go ahead and plug that in your calculator. -1 times -3 squared. So I need 2 of those. Output there is -9. Do the same thing with the -2 value. I'll give you another example here. -1 times -2 squared. I need 2 of those. -2 times -2 is +4. Multiplied by -1 gives us -4. Now I'm going to be kind of quiet there for a second and let you plug away through that. Okay, as you're substituting in, you'll notice as the pattern works down that table, the right side and the left side should look very similar as we graph. When we substitute all of those in, this is our outputs. If you need to pause the video at this time to catch up, go ahead and do that. Let's graph that now. Now, -3, -9 is not going to fit on the graph. So we're going to move on to the next data point. Left 2, down 4. So we're going to go left 2, down 1, 2, 3, 4, lock it in. Left 1, down 1. 0, 0. Right 1, down 1. Right 2, down 1, 2, 3, 4. And the bottom one's not going to fit on the graph. You can see that the left side, the right side are looking to be the same. And this is our graph, y equals -1x squared. So what we're looking at here is what happens when we have a positive a value. We get this graph that shapes upward. When we have a negative a value, we get the exact same graph. It's the exact same shape, but it's actually opening up downward. So positive a value opens upward, negative a value opens downward. Now we're going to need that for the rest of our work today. So moving on to the top of the next page. So what happens when we have a change in the a value? So this is the base that we're going to go by all hour. Here's our y equals ax squared value. What happens as the a gets bigger? Well, first of all, we know as the a is if the a is bigger than 1, if it's positive, we know that the graph opens up. Graph opens up. So as the a gets bigger, what happens, what we're really saying is y equals 1x squared, and then we go to y equals 2x squared, and y equals 3x squared. When the a gets bigger, what happens with the line is the line actually gets steeper. So if I were to graph this one here, y equals 2x squared, we're really saying that it's doubling in size, or it's not doubling, we're increasing it by a product of 2. So we have this value kind of getting a little bit steeper there. It's getting more narrow. Then if we were to graph this bottom one, changing that a value again, it's even going to get steeper. And that should make sense to you even back to linear equations. The bigger the slope, the steeper the line. Because if it's your bank account, your slope is the amount of money that you keep getting over and over. That means your bank account is growing faster. The line should be steeper. That's what it's representing, is how fast is it growing. So what we would summarize in this statement here is, as the a gets bigger, it goes from 1 to 2 to 3. The line actually gets steeper. That's what should be going in that blank there. And what it looks like in our U-shaped graph, it's kind of hard to identify steepness, is it looks like it's becoming more narrow. And that's the terms that we're going to use today. Okay. If you need to pause that video, go ahead. So as our a value gets bigger, the more the steepness changes and the graph gets a little more narrow. What happens if we have a fraction? Well, the graph still opens up when there's a fraction because the a is still positive, but it's actually getting closer to 0. So we're really saying, what happens when a line's steepness is getting close to 0? What do you think about that when we do linear? What does it mean to have a steepness of 0? Well, it means it's not scary. Can you still ski on it? Yes, but it's just not scary. So as the a value starts to approach 0, our graph, now check this out, actually gets really wide. It widens itself. Like this would be y equals maybe 0.5x squared, because we're starting to work our way to 0. So we have this as y equals 1x squared. Now we're going to half, and then we keep getting wider and wider as we gradually go to 0. That should make sense to you that the line is almost going to a straight line with a 0 slope. Y equals 0.1x squared, getting wider and wider. So the graph gets wider as the fraction starts to get closer to 0. So what else can we do with quadratics? Well, we have this a value. We talked about that when it opens up, and when it's narrow and when it's wide. So what about when the graph is negative? So when a is less than 0. So when the graph is negative, all the same rules apply except the graph opens down. Graph opens down. So we've covered this section. If a is positive, it opens up. If a is negative, it opens down. If a is getting bigger, it gets steeper or more narrow. If a is getting smaller, approaching 0, it's going to get flatter or wider because it's getting to be a slope of almost 0. So now let's talk about the c. What the c does is it shifts it. The entire u shifts. The entire thing shifts. If it's plus c, you shift it up. If it's a minus c, you shift it down. No different than when you're graphing a coordinate. So the c would switch that. So here's our equation. If we were to take an equation like y equals x squared minus 3. So here's our original one, y equals x squared. Take the same equation but shift it down. We're just going to shift the entire thing down 3 units. So we're going to move it down 1, 2, 3. Same shape of the graph. And this becomes the graph y equals x squared minus 3. That should not look wider. So I am going to redo that. You know my skills are not that great at drawing. That was supposed to look like the same width there. That's so much better. So much better. But down 3 units. Okay, so some summary stuff for today. What we talked about is all equations that are in the form of y equals ax squared. form a U-shaped graph called a parabola. All of them. They might have some other crap with it, but that's really what's going on there is we get that parabola when we get that x squared. The value of a is super important. It determines the shape of the parabola. If a is positive, it's up. If a is negative, it's down. How do you know if it's facing up or down? I just covered that. If a is greater than 0, so positive, it goes up. The U opens up. If a is less than 0, so negative, the U opens down. How do you know if it's wide or narrow? Well, it becomes more narrow the more steep it is. So as a grows, it becomes more narrow. So when a goes from 1 to 2 to 3 to 4. As a approaches 0, it becomes wider. And what happens with the C value? The C value is either shifting the graph up or down. So shifts up if it's a plus C, shifts the entire U down if it's a minus C. So that's kind of our summary. We're going to do one example together maybe on the next page. So meet me there. All right, let's go ahead and move on. If you need to pause, go ahead and pause right there. So let's take a look at this first example. This is how your entire homework assignment will be. Each one of these, you need to have some blanks written next to it because we're going to make some decisions about it. We're going to decide, does it open up, down? Is it wide? Is it narrow? Are we shifting it? And so on. So we are working off of y equals ax squared. All right. So first of all, it's positive a value, so we're going to say that it opens up. Opens up. Then the next question is it wide or narrow? Well, it looks like the a value is starting to approach 0, so that means it's going to get super wide and become almost flat. So there's my two statements about number 1. Number 2, I'm going to change colors here so you can see on my screen. Looking at the a value, it's positive, it opens up. It's getting steeper. This was a 1 that we're working off of. We went from a 1 to 2, getting steeper, so that means it's getting tighter or more narrow. So the word should be up because it's positive, narrow because it's getting steeper. And a next example, looking at our a value, it's positive, so it opens up again. It's growing even steeper. We went from 1 to 2 to 10, so it's even growing more narrow. That's the plan of what you need to work through on page 3 and 4. Now, if you're struggling, all answers are going to be on my website, so you definitely can go to the website to check the answers if you're confused. Because keep in mind, down here in this section, you're going to have to think about, should I be shifting the graph up or down as well? So these ones down here will have 3 statements. Like, for example, let's take this one over here instead. Just a quick little tutorial. 3 lines. First of all, it opens down because it's negative. It's approaching 0, so it's going to get wide and flat, not scary. And then the entire graph is shifting down 1 unit, the entire graph. Now, I know that was overwhelming, and I jumped all the way to number 9, but I just wanted you to see an example. Again, all answers are on my website if you're needing some to check your work. Finish page 3, 4, due tomorrow. Have a fabulous night, 8th grade.